ATP synthesis of Enterococcus hirae V-ATPase driven by sodium motive force. Akihiro Otomo, Lucy Gao Wei-Zhu, Yasuko Okuni, Mayuko Yamamoto, Ryota Iino. V-ATPases generally function as ion pumps driven by ATP hydrolysis in the cell, but their capability of ATP synthesis remains largely unexplored. Here we show ATP synthesis of sodium ion transporting Enterococcus hirae V-ATPase, EHVOV1, driven by the electrochemical potential gradient of sodium ion across the membrane, sodium motive force SMF. We reconstituted EHVOV1 into liposome and performed a luciferase-based assay to analyze ATP synthesis quantitatively. Our result demonstrates that EHVOV1 synthesizes ATP with a rate of 4.7 per second under high SMF, 269.3 mV. The Michaelis constants for ADP 21 micromolar and inorganic phosphate 2.1 millimolar in ATP synthesis reaction were comparable to those for ATP synthases, suggesting similar substrate affinities among rotary ATPases regardless of their physiological functions. Both components of SMF, membrane potential, delta psi, and sodium ion concentration gradient across the membrane, delta PNA, contributed to ATP synthesis, with delta PNA showing a slightly larger impact. At the equilibrium points where SMF and Gibbs free energy of ATP synthesis are balanced, EHVOV1 showed reversible reactions between ATP synthesis and hydrolysis. The obtained sodium ion to ATP ratio 3.2 closely matched the value expected from the structural symmetry ratio between AVO and EHV1 3.3, indicating tight coupling between ATP synthesis and hydrolysis and sodium ion transport. These results reveal the inherent functional reversibility of EHVOV1. We propose that the physiological function of EHVOV1 in vivo is determined by relatively small SMF against large Gibbs free energy of ATP synthesis. In addition to the absence of inhibitory mechanisms of ATP hydrolysis which are known for ATP synthases,